We use FlyWeight design pattern in cases where we can optimize memory usage of the overall system by sharing common state of objects. So basically we reduce the amount of memory overall system is using by sharing the common properties of objects. Let's take the example of a computer war game like Age of Empires. You may be showing hundreds to thousands of soldiers. Now even though there are so many soldiers on the screen, and each soldier has a 3D image object associated with it, but the type of soldiers is limited. Basically 8 to 10 type of soldiers will be there, like foot soldier will be there, archers will be there, knights, that is the soldiers who ride horses, will be there. And basically two foot soldiers will look alike, or two three different archers will look alike, their 3D objects will be same, or two or three different knights will look same, their three, that is their 3D image objects will be the same. So what we can do is we can share these 3D image objects of these different types of soldiers across all the soldier types, and we can therefore thereby reduce the overall memory of the system drastically. So in this case, using FlyWeight design pattern is a good idea. Again, let's take the example of a text editor. Even though there can be 10,000 or 100,000 characters in a text editor file like that of a Microsoft Word, basically the number of styles that we use in a single text editor file is limited. We do not use more than a few hundred styles in a text editor. So what we can do is we can basically share the styles of different characters among the different characters, and this will also reduce the overall memory usage of the system. Styles of the character include the color of the character, the font type, the font size, whether the character is bold, italic, or underlined. So let's see these things in detail. For implementing a FlyWeight design pattern, there are two parts. The first one is the intrinsic data, that is data which is constant and doesn't change. In the case of our text editor problem or the text editor design, the data which is constant can be something like this string, where J is the character, Arial Black is its font type, 14 is its font size, whether it's bold and italic. So this will be the constant data which can be shared across different characters, and extrinsic data will be, that is the changing data, will be the same character or the same style can be added in different rows and columns. So rows and columns will keep on changing. So how do we implement the factory design pattern? Basically, these two can be merged into one. We may need an interface, or we can directly go onto a concrete FlyWeight object. If we may we'll see an example how we implement it. So the intrinsic state will be there, that is the state which will be shared as constant across different objects. This will definitely be there. There will be a factory class which will definitely create the intrinsic state. About the operation, that is the method which changes the extrinsic or changing data, it can be implemented slightly differently, that we see in an example just now. So let's go ahead and look at that. So let's look at a real interview question. We have the question: design a text editor or word processor like Microsoft Word. So I have already opened it. Basically, any Word, Microsoft Word file or any text editor file, you can think of it as a 2D array. So what we do is we add characters and their styles in different rows and columns. So when you are adding a string with different style, it is actually just a collection of characters that we are adding. So what this method does is it adds a character in row and column, and then there is the style information of the character, which is font name, font size, whether the character is bold or whether it is italic. So just now we discussed the FlyWeight design pattern. So for the constant data, I have created or the intrinsic data, I have created a char FlyWeight object. It contains the character, it contains the font name, the font size, whether the font is bold and whether it is italic. So this is the intrinsic data, and this intrinsic data will be created using a FlyWeight factory, and I have implemented the extrinsic or the changing data slightly differently, that we will see. So as you can see in the FlyWeight factory, there is a method create style which takes a character and its style information, and then what it does is basically it appends to form the string, this string. Let me just show you. So this is the string that that method is forming. So J is the character, hyphen Arial black is the your font name, 14 is the font size, B is whether the character is bold, I the whether the character is italic. So once this key is formed, it checks in the map whether a style object already exists. If it doesn't exist, then it inserts a new style object, and finally it fetches the style object against the corresponding key and returns it. So this gives us the benefit that for the same style and the same character, object is not recreated, rather it is reused and shared. So how does the client uses this FlyWeight factory? So class solution is our client. Class solution is where the code execution starts for all questions in code gym. So we have created a FlyWeight factory instance variable right here. In a real world code, you will generally inject this factory object through the constructor of the solution class. But here our constructors will be empty, so we have not. You have just initialized it as an instance variable. And in the add character method, where we need to add a character in the row and column. So as you can see, our extrinsic data, that is the changing data, which is the row and column of the character, how we have implemented it. We have implemented the whole your text file or word file as a list of text rows, and each text row will have multiple columns. So how we are adding it? First of all, for the corresponding style, we are creating a style using factory. Now we know that factory either creates a new style or fetches an existing style. Once that style is fetched for the with the corresponding character, we add it to the corresponding row and the column. So rows dot get row, that is the corresponding row, and then it adds to the corresponding column. So this is how the client uses the factory to create the intrinsic object. And here we have, rather than keeping the extrinsic data in the FlyWeight object itself, we have kept it outside, that is in this array list, inside this array list and inside the text row. So this is how we see that even though there can be tens of thousands of characters, since the number of styles they use is limited, so we were able to reduce memory usage of the overall program using factory design pattern. If you want to take away just one thing about FlyWeight design pattern, then just remember that wherever you have the opportunity to optimize, that is reduce your memory usage of your overall program by sharing common state, that is parameters of different objects, then FlyWeight design pattern will be a good idea to use there. So this was all about FlyWeight design pattern. I have created a preparation plan for low level design interviews. So basically it's a 7-day plan and you can access it on coaching.com/roadmap. It has everything right from how do you get interview calls to what to expect in an interview, to all the basic design patterns and important topics video, and day by day practice problems. So whenever someone starts preparing for LLD interviews, they are a bit confused because the time is less. The interview is scheduled in like this week or next week, so they have hardly 7 to 10 days to prepare. And there is a lot of content on the internet and lots of videos on YouTube. So people need to know what things to watch on priority, which topics to uh, see first, which questions to practice first. So this tutorial has everything. They are basically daily short videos and daily practice question for each day. So just give it a go and it will help you prepare efficiently for your LLD interviews. Thanks a lot for watching this video. Bye.